My name is Brandon Burdett, and this is my Lab 2 lines of charge. In this lab, the experiment was the same as in Lab 1, which is to place one piece of charge tape underneath another, causing it to float. For the coding in this lab, I was tasked with creating a computational model of two lines of charges experiencing the effects of their electric fields and the force of gravity. And then also the purpose of all this is to examine the effects of electric forces. Here's a preview of the coding output, which shows the force of gravity going down, all of the forces of the electric field going up, and the total electric force going up as well. One of the principles within this lab is system versus surroundings, and a system is the object you're observing, which is the floating tape, and the surrounding is everything else, which is both the earth and the lower tape. Another important physics principle is understanding how vectors work and how when you're subtracting them, it goes from the location that you're observing minus the location that the charge is coming from. Now, the important forces to know for this lab are the force of gravity seen on the left and the electric force seen on the right. Now, getting into the specifics of the experiment, we created a U-tape by ripping one tape from the top of another tape, which was stuck to a table, and then you hold one of these U-tapes below another U-tape, and then the top one will float. And this is because they both have the same charge and they're repelling when they're close to each other. Now here's a picture of what this experiment is supposed to look like with the B-tape on the top floating. And here is one picture of our group trying to get this to work, which in this actual picture we did not, but eventually we were able to hold it the way it was in the last picture, and we were able to get it to float. Now for the GlowScript computational model. Before getting into the coding, some of the important assumptions include knowing that each tape is treated as a line of many point charges, and each U-tape has the same overall charge. Now, our initial conditions for this lab include the electric constant, the gravity constant, the mass of the tape that we measured, and then also the estimated net charge that we calculated in our last lab. Now on to the actual calculations. Here in the top, we are calculating the electric field using E equals KQ over R squared times R hat. And then here on the bottom, you can see the creation of the line charges of the tapes that you'll see on the output. Now this loop seen here is going through calculating the electric force, the electric field, and the force of gravity, and this is also creating the arrows that you'll see on the output. Now this part of the calculation creates the big arrows, which show the overall electric force and the overall force of gravity. Now here's that end result that we looked at earlier, and the green arrows going upwards are all of the electric forces from the different point charges, and then the big white arrow is the overall electric force, which is going up, and it's very similar in magnitude to the yellow arrow going down, which is the gravitational force, and you can see the numbers for these two at the bottom, with all of the red and blue particles representing the tape. So the result of this coding ended up looking as it was supposed to, but this was because I had to change the net charge on the tape compared to what I actually ended up finding in Lab 1. Now, this could have been due to many different things, such as the tape losing its charge for waiting too long or touching it, or using the wrong side of the tape so it's not the right charge. And I also could have had some errors within my coding for either this lab or the last lab. The value of the charge when using the point charge model and the line charge model are a little bit different, and here on the next slide I can kind of tell you why that is. The reason that these values are a little different is because one assumes that all the charge is coming from the same spot, while the other assumes that all of the charge is coming from various distributions across a line, and this line charge is definitely more accurate because this is closer to what's happening in reality, where the charge is spread across the entire tape rather than just a point. Thank you for listening to my Lab 2 video.